learned about the movement of the earth.
Hi everyone, I'm Dinesh Samudika from Faculty of Education, Horizon Campus. Today I'm going to talk about plate tectonics theory. Before that, I'm going to explain what is plate tectonic theory. Plate tectonic is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. The theory, which solidified in the 1960s, transformed the earth science by explaining many phenomena, including mountain building events, volcanoes, and earthquakes. In plate tectonics, Earth atmosphere or lithosphere, made of the crust and upper metal, is broken into the large rocky plates. These plates lie on top of partially molten layer of the rock called atmosphere. Due to the convection of the atmosphere and lithosphere, the plates move relative to each other at different rates from 2 to 15 centimeters, like 1 to 6 inches per year. These interactions of tectonic plates is responsible for many different geological formations, such as the Himalayan mountain range in Asia, the East African Rift, and the San Andreas Fault in California, United States. The idea that continents move over the time had been proposed before 20th century. However, a German scientist named Alfred Wegener changed the scientific debate. Wegener published 2 articles about a concept called continental drift in 1912. He suggests that 200 million years ago, supercontinent he called Pangaea began to break into pieces, its parts moving away from one to another. The continents we see today are fragments of the supercontinent. To support his theory, Wegener pointed to matching rock formations and similar fossils in Brazil and West Africa. In addition, South America and Africa look like they could fit together like jigsaw puzzles. Despite being dismissed at first, the theory gained steam in the 1950s and 1960s as new data began to support the idea of continental drift. Maps of the ocean floor show a massive undersea mountain range. Maps of the ocean floor show a massive undersea mountain range that almost circle the entire Earth. An American geologist named Harry Hess proposed that these ridges were the results of molten rock rising from the atmosphere. As it came to the surface, the rock cooled, making new crust and spreading the sea floor away from the ridge in a conveyor belt motion. Millions of years later, the crust would disappear into ocean trenches at places called subduction zones and cycle back into Earth. Magnetic data from the ocean floor and relatively young age of oceanic crust support his hypothesis of sea floor spreading. Plate tectonic theory dealing with the dynamic of the Earth outer shell. We called it as a lithosphere and also a plate boundaries. Lithosphere is broken up into 7 very large continental and ocean-sized plates, and plate boundaries is more geological activities like volcano, earthquakes, and mountains. There are 3 types of plate boundaries: convergent, divergent, and transformation. The other members of my group will explain what are the things included in the plate tectonics theory and its overview.
So, what are the pieces of evidence? From almost the creation of the first true maps of the Earth, people started seeing how continents would be able to fit together. In particular, people noticed about South America fits almost exactly into Africa. Significant evidence of plate tectonic theory. First one is continental drift. Observation of continents fitting together like puzzle pieces suggested they were once connected. Third one is subduction zone. Identification of deep ocean trends were oceanic crust sinks provided evidence of crustal movement. Third one is earthquake and volcanic activity. Distribution of earthquakes and volcanoes along plate boundaries supported idea tectonic plates interacting. Fourth one is seafloor spreading. Discovery of mid-ocean ridge and magnetic stripping on the ocean floor indicated new crust forming at these ridges and spreading outward.
The theory of plate tectonic, a groundbreaking scientific advancement, fundamentally transformed our understanding of the Earth dynamics. It illustrates the large-scale movement of the Earth lithosphere, which consists of the crust and upper midline. This theory is underpinned by the two prevalent hypotheses. Continental drift and seaport spreading each contribute in the compelling evidence towards the comprehensive plate tectonic.
So, when we talk about plate tectonics theory, we find two components of plate tectonics theory. One is lithospherical plate and then the plate boundaries. So, here we have a globe, and then when we talk about the Earth, we see the outer layer of the Earth is lithosphere. We call it outer layer of the Earth as lithosphere. So, this lithosphere or the outer layer, we find different plates in this lithosphere, and then these plates, they move here and there. So outer surface of the Earth is in motion, so that means we see the lithosphere of the Earth is in motion and they move here and there. Edge of the Earth is known as plate boundaries. So when we talk about the types of plate boundaries, we have mainly three types of plate boundaries. One is a convergent boundary, the divergent boundary, and the transform boundary. Convergent plate boundaries. When two plates are coming together, they are known as convergent plate boundaries. So when these two plates are coming together and they come and they collide, and convergent plate boundaries are known as also a destructive, because when they come together they collide and there is a kind of a destruction taken place. So for example, we can take the Himalayas mountain range. So it's because of these two plate boundaries, when they come and collide, so Himalaya is growing still. And the divergent plate boundaries, when these two plates move in apart from each other, they are known as the divergent plate boundaries, also known as creative, because when these two plates are moving apart, so magma, which is there in the middle of the Earth, they come up, they rise up, and then they create a new land, new crust. Because of that, we call it creative plate boundaries also, because it creates something. And the transform plate boundaries, and there is neither destruction nor creation is taken place. Transform plate boundaries are the plates, they go horizontally passing each other, they slide passing each other. So those are called the transform plate boundaries. So when it comes to this plate tectonic theory, it is the Alban Wegener who first presented this hypothesis.